All right, guys. So once again, solving one-step equations. So one-step equations, and for those of you that probably know me by now, you understand that pretty much I see like math or numbers everywhere I go. And it's something that sometimes I can't turn it off, and many times by the end of a day, I'm very tired of thinking so much. I don't know why. Because sometimes you can't stop your noodle from thinking. So sometimes I'm at the market and I see something and I like it, and I see math in it. So let me show you a quick video so you guys can check it out. Can you get the lights, please?
Alright guys, this is Mr. Q here. Hi, I'm here at Cardenas doing some shopping, check it out. And basically what I'm going to do, I'm going to buy some pears. They're on sale right now for 79 cents a pound. So basically how this works, I put some pears in a bag, like so. And then I weigh them, and to weigh them I need to put them on the scale, so check it out. Here goes the scale. This is the scale. Now this works right now, it's showing 3 pounds right there, so that means that 3 times 79 or 3 times 80, that's about $2.40. And pretty much that's how scales work, is to weigh stuff and to give you an accurate measure, but we say that it's an estimate. But this is just to show you how math is used on a daily basis. And equations, now that we're going to be introducing equations after expressions, are based on scales. And scales, not this type. This is already like a more modern type of scale, but there's an actual scale that looks like a actual balanced equation, and I'll show you that later on when we introduce it. All right? Just wanted to show you how it's used on a daily basis. So let me do some shopping and enjoy the video, and I'll take you guys out once we get started. All right? All right. See you in a bit. Bye.
Yeah, that's what I was going to say. Lights, please. Yeah, if you guys notice, I was first looking to one side and then looking to the other, because guess what happens is that you guys are used to people doing this, right? Getting their phone and going like this to take a selfie, right? That's something that's common. What's not common is I didn't have my phone like this. I actually placed it on the little cart. And since I was just like grabbing stuff and talking, and all of a sudden here comes one family, and then all of a sudden I was talking while I was getting pears, and all of a sudden they stopped, and then the lady said, disculpe? Like they started talking to me, and I was like, and I didn't want to stop recording because I wanted to record the video, so I just kind of like turned this way, and I kept talking. So then I was being nice. I didn't want to be like rude and you know, interrupt the video. So then when I turned this way and I kept talking to the video, guess what? Here comes another family, and they didn't say anything. They just stopped and looked at me, and I'm like, okay, so I just turned the other way, and I kept recording. So yeah, so probably think I'm crazy, but that's fine. I just wanted to make a point and connect it to the lesson. Hold on. So this is the connection, though. I wanted to see for you guys to see that we still use scales on a day-to-day basis, right? But in the past, these were the kind of scales that were used. Look up to the screen. So these kind of scales, where they had 2 pans. The one that they had at Cardenas was only 1 pan, and you just put stuff in it weighs, right? So check this out. So let's say I had a store, and in my store I have one of these. And how this works, if you notice, there's little weights down here. Do you guys see those different sizes? Each weight has a different weight measure. So for example, this one right here would be probably 1 pound, worth 1 pound. So let's say at my store, I sold groceries. So here comes in Hannah, and she's like, Mr. Q, I want to buy 1 pound of frijoles. I'm like, all right. Let me get my little weight. I'm going to cut it out from here from the picture. And I place it there. Boom. So this is 1 pound worth of bronze or whatever that is. And that's going to make that side go down. Is that correct? And in order for this to be balanced, what do I need to add to this side? 1 pound of whatever it is we're going to purchase, right? So that's what makes it even. And that's where your other teachers in the past used to say, and whatever you do to one side, you do to the other side, just to keep the scale balanced, right? Now check this out. So to continue like that, there's another type of scale that you probably already seen in dollar bills or at those jewelry stores. They have these kind of scales, and they work the same way. If I add 8 pounds to this side drops, but in order for it to balance out, I need to add 8 pounds to this side. Does that make sense? Same thing, if I add to this side 11 pounds, what do I need to add to this side? 11 pounds, and it balances out. Well, guess what? Another mathematician that thought of mathematics everywhere he go. Let me first draw the base of this scale. They used to have nice designs like this. Kind of, sort of, yeah? All right, so usually when you were at the market, they would have their table, and here's a table right here, and there's a scale. And the mathematician, when he left, he turned back, and from far away, all he could see is the bar of the scale and the edge of the table. And the farther he got, what does that look like if you were walking away?
Oh, it does look like a nose. That big thing looks like a nose. It does look like a nose.
So from equations, we all get equal signs. And the equal signs come from the balancing the scale. I know, right? Thank you. Now check this out. Let me hold on. Give me a second. Now let me elaborate a little bit more on this same topic of the scales. So if I was to take a step back, look up, please. From this same scale concept is where we get the following. What's in here in this pan right here? 0, and over here it's 11. And let me show you, where was the bar originally before it went down? It was about right there. Do you guys see? Do you guys see it? Boom. That just happened. So inequalities also come from, let's see, if you don't see it, here goes again. Look up. Some of you don't see it. Let me start like this. Okay, here it goes. How many pounds on this one? 8. On this one, 0. What was the original, where was the original bar? Right there. But now it's like this. Therefore, this is that way. Everybody see that? So today we're not looking at inequalities. I just wanted to show you the same concepts coming from scales. We're looking at what? Equations, all right? So our objective for today, I can solve and graph one variable equations. We read it together, 1, 2, 3. I can solve and graph one variable equation. So write that down, please. And you do need a Ferrer model since we're starting a new concept. And loosen up your wrist because we are going to be writing some stuff down. Okay, here we go. One variable equations, what are they? One variable equations are mathematical statements where two expressions are equal to each other and contain one unknown variable. One variable equations are mathematical statements where two expressions are equal to each other and contain one unknown variable. One variable equations are mathematical statements where two expressions are equal to each other and contain one unknown variable. One variable equations are mathematical statements where two expressions are equal to each other and contain one unknown variable. Examples: x plus 2 equals 25, 12 equals y minus 8, 2a equals 14, negative 3 equals m over 4, or m divided by 4. Also, 3x plus 2 equals 25, 12 equals 4y minus 8, 2a plus 8 equals 14, and negative 3 equals m divided by 4 minus 6. Copy that, please. All right, let's see. According to the definition, let me go over this. Mathematical statements. So basically, a mathematical statement should look something like this. Okay, but here's the key part of the statement. It's two expressions equal to each other. So let's see. Is x plus 2 an expression? Yes. Is 25 an expression? Yes. If it has an equal sign, that means that they are equal to each other. Is that correct? Now let's read the last part. One unknown variable. Does this statement have one unknown variable? Yes. Okay. Let me go to this one. Is 2a an expression? Yes. Is 14 an expression? Yes. Equal to each other? Yes. And one unknown variable? Yes. Look at this one. Expression, expression, equal to each other, one unknown variable, and so on and so forth. Fairly simple? All right, let me show you some non-examples. Now that we're clear as to one variable equations. X plus 5 minus 25, 12 greater than x minus 8, x squared plus 5 equals 30, 4x plus 6 equals negative 2y. As you're writing this down, start thinking, if these are one variable equations, why are these not? Number one, think about that. Why are these not? But I also want you to think of each individual example as to why they're not a one variable equation, and if you know a name for that non-example. So why are they not, and if you know the name for that non-example. Talk it over with your neighbor. Why are these not, and if you know a name for each of those non-examples. Let's look at the first non-example, this one. Why is that not a one variable equation, and what is the name of it? Go ahead, Jeremiah. It's an expression. And does that cover as to why it's not a one variable equation? Yes? Why not? Jeremiah? Does that cover it? Okay. That is correct. This is an expression, no equal sign. Pass to someone, please. Close. Everybody look up, guys. Do you agree that this is an expression? No, that is not an expression. Who can help him out? Okay, go ahead, Hannah. Inequality. And because it's an inequality, it's not a one variable equation, and it's obvious because of the inequality symbol. Okay? Pass someone, please. Hannah. Lisa. Be nice. Why is this not a one variable equation? Did you ever hear what she said? Technically, I would say yes to that answer, but let's see if we can elaborate again. Here it goes. She said, because it has an exponent. Let me stop you right there. What would you add to that? It has an exponent. Look at these, and look at this. It has an exponent. It has an exponent. Pass to someone? Viviette? Does everybody agree with that? Yes, that is correct, because all these have exponents of 1. This one has an exponent greater than 1. Now, Charlie, you wanted to add something? Okay. Now, technically, if we were to split this one up, it's still x, isn't it? And it could qualify as a one variable equation, but this one we call it a quadratic equation. Quadratic equation once it has a square. You guys remember polynomials? Yeah. To the second degree, it's a quadratic. We're going to be looking at these, by the way. Last example, Liviette, pass it to someone. Christine? This one's not a one variable because it has two variables. So, Christine, this is not a quadratic. This one is not. What would be another name for this one? Okay. Look at these, and these are called this. So what is the name of this one? That is correct. This is a two-variable equation, and we are going to be looking at those. We are going to be looking at systems of two-variable equations, and we're going to be going into some Algebra 2 with systems of three-variable equations. Yes. Yes. Okay. Therefore, let's do some hashtags. What are three things that we need to know in regards to one variable equation? Tell your neighbor some hashtags. We need three of them. Okay, Charlotte, give us one. Hashtag one variable. I got that. Pass it to someone. Be nice. Caleb, what's another one? Equations. All right. So far, so good. We need something very important at the end. Pass it to someone. Wow, be nice. Who? Lily. Okay, we got one variables, which they do have. We got equations, which they do have equal signs. What is the third thing that we covered over here on the non-examples that needs to be in here? Be nice. Pass to someone, Lily. Jocelyn.
Hashtag, not greater than one.
The other way. Oh yeah, not greater than one. Yeah, I'll take that. Not greater than one exponents. Not greater than one. Yeah. Yeah, that's a long hashtag, right? But I've seen longer hashtags. I've seen some of them on Facebook put hashtag I want to go home, be Friday, please. I'm like, really? That's a hashtag? Wow.
I do it one at a time. Hashtag I, hashtag one, hashtag two.
All right, so with that said, let's move on. Steps. Write these down. It's only 4 steps. Number 1. Step 1. Simplify each side of the equation. Do we know how to simplify? Yes. Yeah, I'm saying you better say yes because we've been simplifying expressions since the beginning of the school year till now. Yeah, simplify each side of the equation, which means start with grouping symbols and then combining like terms. Step 2. Isolate the variable by using inverse operations. Step 3, plot your solution on the real number line. Step 4, check your solutions by substituting the value of the variable into the original equation. Copy that, please. All right. Here we go. So really quick, to clarify the steps. Step 1 is simplify each side. Do we know how to simplify expressions? Yes, because each side of the equations are 2 different expressions. We know how to simplify. Isolate the variable. So the word isolate, so I want to clarify that for some of you that don't know what that means. I know you guys don't get referrals, but maybe your friend had a referral, and on the referral, one of the check-off boxes for the teachers says isolated the student. Isolated the student. Let me explain what that is. For example, let's say here in class you're messing around, and I'll be like, Hannah, can you please cut it out? And so, okay, so then she goes to work, right? She's cut it, and again she continues like poking somebody over here on the sidewalk. Hannah, please. Okay, and then I keep going, and I'm about to continue the instruction, and she starts singing in the middle of the class, and I'm like, wow. So she continues to disrupt the class, and then I say, you know what, Hannah? Next time, if you do it one more time, I'm going to send you to the desk, all right? So then she's all right. So then she's over there, and all of a sudden I see her doing this. And she's passing on, okay, Hannah, move over here to the desk. So she moves to the desk. There she is. By the fact that I took her away from the group, that's called isolated the student. What does isolated mean? That she's left by herself. Same thing. Step two of here, it says isolate the variable. We need to leave the variable by itself using number of operations. Okay? So, plot your number on the number line and check your solution. So, two things that I want to make sure you remember, look up. There's two more properties that we're going to add. Don't write this down, just to clarify. Here goes addition, subtraction, multiplication, division in context of an equation. Look up, please. So, look at this equation. Do you see how it has addition? It's being added to this side. So what would be the inverse? Subtraction, right? How about here? Subtraction of 8. What would be the inverse? Addition. This one is multiplying 2 to the variable. What is the inverse? Division. And here, this variable is being divided by 4. What is the opposite of dividing by 4? Multiplication. Everybody got it? And the two properties that I'm introducing that you should already know are these two: addition, property of equality, and subtraction, property of equality. What does that mean? Whenever we add something to each side of the equation, it's called addition, property of equality. Therefore, if we subtract something to each side, what is it called? Subtraction, property of equality. Copy this down. Example 1. Solve the equation and check your answer. If it doesn't fit in the front, turn your paper over. Yes?
Is there like a section? No, like this stuff like example? Or are they
Yeah, in the back. The Cornell notes, you should have Freire model, steps, turn the paper over, and in the back are the examples. And if they don't fit after your many, then you get another page. Yeah. All right, here we go. Example number 1 says, solve the equation and check your answer. So, to remember that this comes from scales, balanced scales, I want you to draw a line down the equal sign, and that would get your imagination thinking left side and right side. Do you guys see it? Okay? So with that said, step 1 says simplify each side of the equation. Can we simplify this side anymore? No. How about this side? No. We can't combine like terms or distributive property or anything like that, right? Therefore, step 2, isolate the variable using inverse operations. So what is the operation right now here? So what the inverse would be, so we add 3, and whatever we do to one side, we do to the other side to keep it balanced. This cancels because it's a 0 pair. Bring this down, y equals, and this is 7. Yes? No, we're going to get there. Thank you. So the solution to this one is y equals 7, yes? So step 1, did we check for simplification? Yes. Step 2, isolated the variable? Yes. Step 3, plot your solution. Let's plot our solution. Here we go. Draw your number line. 0. We got 1, 2, 3, 4, 5, 6, 7. And plot your answer. Step number 4 is check. So I'm going to write my original equation, this one. I'm going to write it down here. Y minus 3 equals 4. But instead of y, what am I going to write? 7. So this is 7 minus 3 equals 4. What is 7 minus 3? 4 is 4 equal to 4? Yes. And that's how you do those. Okay? Okay? So now, I think, let's see, the one thing that I did skip, I noticed, on our steps. Look up. On the steps, circle these 4 keywords. Step 1 is simplify. Step 2 is isolate. Step 3 is plot. Step 4 is check. So the 4 keywords that you're going to remember the process are these 4. Simplify, isolate, plot, check. 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 All right, thank you. Let's see if we got it. Look up. Now let's make sure we did all 4 steps. Did we check to simplify? Yes. Did we isolate the variable? Yes. Plot it? Yes. Checked? Yes. All right. So copy this one. Example Q. Let's do x plus 6 equals negative 2. Solve that one. Use that process. What are the 4 steps? Tell your neighbor, please. Thank you. Yes. Follow that process. Go. All right, let's see. So for this one, look up, please. You drew a line down the equal sign? Yes? Then you did, thank you. We did minus 6, x equals negative 8. Hands if you got that. Okay. You plotted your solution. We got 0, 1, 2, 3, 4, 5, 6, 7, 8. Nice and straight like mine. There it is. And at the end we did our check. And of course it's going to write whatever it wanted. Look at that. My goodness. Check. Check. So I did x plus 6 equals negative 2. So I substitute negative 8 plus 6 equals negative 2. Negative 2 equals negative 2. And that worked, yes? All right, so what I want you to do now, underneath that, do you have space? Yes, right? I want you to rewrite this problem again. Just write y minus 3 equals 4. And now what we're going to do, we're going to use cups and tiles. Get those in front of you, please. Yes? Okay, I'll explain in a little bit. So, here it goes. Really quick. The first thing that we have is the same problem, y minus 3 equals 4. Is that correct? So, cups and tiles, how they work, here it goes. It's going to go really quick. For every variable that we see, we use 1 cup. If it said 2y, we would use how many cups? But since in this case it's only 1, so you put 1 cup. There it is. 1 cup. What is the next thing they ask us to do? Or negative 3. 1, 2, 3. Everybody see that? Next, the equal sign. How do we represent the equal sign? Draw a line down. There it is. Everybody follow? Okay. Next, what's on this side of the equation, everyone? 4 positives. 1, 2, 3, 4. All right. Therefore, see what I did there? So, what did we do to cancel these right here? Okay, I'll wait. You guys ready? Okay, we need a 0 pair, so that means we need to add 3. 1, 2, 3, and whatever we did to one side, we do to the other side. 1, 2, 3. Take away the 0 pair, and we get what? y is equal, oh, we can barely see the other one. There it is. Y is equal to 7. Everybody got it? Now, for home play, I don't want you to do custom tiles. We're going to continue with this tomorrow. But I do want you to solve using the process that I gave you today, okay? The play sheet is in the back, play sheet 2.2. So make sure, work on that tonight. Have a good one, everyone. Enjoy your home play. See you guys tomorrow. Home play is play sheet 2.2. Bye.